Hi everyone, myself Vinay Kumar and my channel is Vinay Kumar Basics of Physics. Now onwards, I want to upload the Gurukula Physical Science Pgt TGT portion, paper 3 content in our channel. So if anybody interested to learn, just follow my channel regularly and subscribe my channel. Okay, without late, coming to the point, here units and measurements. This is one of the most important concept that is going to be gain more score in the exam. Clear? So here in this video we are going to discuss about the what is physical quantity and how many parts in a physical quantity and how many types of physical quantities are there, what are fundamental quantities and what are fundamental units and what are derived quantities and what are derived units and how many system of units are available and what are the definitions of different type of units and what are the rules to write and mention the SI units. So this content will be available in this video, that's why watch the video up to last without any skip. Clear? The first thing is, what is a physical quantity? In physics we can use the word physical quantity very repeatedly. What is the physical quantity? A quantity that can be measured and expressed as per laws. That should be what we call physical quantity. So what is the necessity of measurement? What is the necessity of measurement? Measurement is compulsory to mention and measure quantity of physical quantity. How much quantity is available for a physical quantity? To know that, the measurement is compulsory. Okay, after finding the quantity of the physical quantity, magnitude of physical quantity, how it can be expressed? It can be expressed by using some units. Again, what is unit? Measurement of a physical quantity involves comparison arbitrarily and internationally accepted with a standard basic. That should be called unit. So here exact definition is here. Measurement of any physical quantity involves comparison with a certain basic and arbitrarily chosen internationally accepted reference standard or basic standard. It is also called as unit. And measurement of physical quantity consists of two parts. One is the magnitude of the quantity, and second one is the name of the unit. Clear? So here measurement of physical quantity is equals to magnitude into name of the unit. For example, we are saying now we went to some shop and purchased sugar of 5 kg. Here 5 is the magnitude and kg is the unit. And nearly we are saying that 5 kilometers we are saying now, or we are saying some 500 meters. The numerical value what it is there, that should be taken as the magnitude, and the remaining portion should be what it represents. It represents the name of the unit. So in this way any physical quantity going to be expressed. Clear? So okay, measurement of physical quantity అన్నప్పుడు ఆ physical quantityకి టూ పార్ట్స్ ఉంటున్నాయి. ఒకటి magnitude అంటున్నాం, ఇంకోటి నేమ్ ఆఫ్ ది యూనిట్ అంటున్నాం. సో 5 kg అన్నప్పుడు 5 is the magnitude అవుతుంది, kg is the unit అవుతుంది. and there is some relation between the magnitude and unit, that is inversely proportional. We are saying now n into u is equals to constant. Here what is n? Magnitude. And what is u? Unit. And here the relation is n is proportional to 1 by u. It is also expressed like this: magnitude of the physical quantity is inversely proportional to the unit. That means if one quantity is less, another quantity is more. Clear? So here we are going to say that now here n1 u1 is equals to n2 u2. For example, here I am writing here 1 kg is equals to 1000 grams. So here n1 is 1, u1 is kg, and n2 is 1000, u2 is gram. Actually here gram is the less quantity. Then its magnitude is what? How much is more? It is more. And similarly here 1 kg it is there, 1 is here less, and kilogram is the highest one or more value, or highest unit. So when the unit is more, magnitude is less. When unit is less, magnitude is more. That is the relation between the magnitude and unit. ఒక ఫిజికల్ క్వాంటిటీ యొక్క మాగ్నిట్యూడ్, దాని యొక్క యూనిట్ ప్రమాణము రెండు ఎలా ఉంటున్నాయి? ఇన్వర్స్లీ ప్రపోర్షనల్ ఉంటుంది. ఎప్పుడైతే యూనిట్ అనేది చాలా తక్కువ ఉంటుందో దాని యొక్క వాల్యూ ఎక్కువ ఉంటుంది. అదే ఇక్కడ చెప్పాను, 1000 grams అంటే గ్రామ్ అనేది CGSM, ఇట్ ఈస్ లీస్ట్ వాల్యూ ఆఫ్ యూనిట్, అన్నట్టు. దెన్ ఇట్స్ మాగ్నిట్యూడ్ ఈస్ మోర్. కేజీ ఈజ్ ద హైయెస్ట్ ఆఫ్ యూనిట్స్. మాస్ సంబంధించి గ్రాము, కేజీ ఇవి రెండు మాస్ యూనిట్సే. వాటిలో లీస్ట్ వన్ ఏంటి? గ్రామ్. అంటే చాలా ఎక్కువ చిన్న వాల్యూస్ గురించి చెప్పేది గ్రామ్ అంటాం ఇక్కడ. సో ఇక్కడ హైయెస్ట్ వాల్యూ కేజీ. సో హైయెస్ట్ యూనిట్ కేజీ అవుతుంది, దాని యొక్క లీస్ట్ వాల్యూ 1 అవుతుంది. ఇక్కడేమో లీస్ట్ యూనిట్ ఏమో గ్రామ్ అవుతుంది, హైయెస్ట్ వాల్యూ ఏమో 1000 అవుతుంది. సో దట్ ఈస్ ద రిలేషన్ బిట్వీన్ దీస్ టూ. యూ హ్యావ్ టు రిమెంబర్ దట్. Physical quantities can be classified into two types. They are the fundamental or base quantities, and second one is derived quantities. Fundamental quantities and derived quantities. Which are called fundamental quantities? The physical quantities which are independent of other, they are called fundamental or base quantities. The quantities which are independent means what? They are not depending on any other quantities. That type of quantities are called fundamental quantities. And derived quantities, the quantities which can be derived by using fundamental quantities, they are called derived quantities. Look here, fundamental quantities means what? Which are independent of other quantities. It means that not depend on others. Okay, that should be what we call fundamental quantities. Example here: mass, length, time, temperature, etc. Clear? Derived quantities, the physical quantities which can depend or which can be derived by using base quantities or fundamental quantities. Fundamental quantities, that should be what we call derived quantities. To understand that, I will give an example here. Speed is equals to what? Distance by time. Speed is what? Distance by time. So here speed is now what you have to say? Derived quantity. Why? Because that should be depend upon the distance and time. Here distance is nothing but what it is, nothing but here length and time. That means the speed can be depend upon the base quantities. That's why that should be taken as it is derived quantity. So similarly here we can take any formula that is derived quantity only. F is equals to ma. Here what is F? Force. What is M? Mass. What is A? Acceleration. So that should be here, it is now derived quantity. I can take acceleration, that is what? Velocity by time. Velocity, change in velocity or velocity for time. This is also derived quantity. That is the main difference between the fundamental quantities and derived quantities. ఏ క్వాంటిటీస్ అయితే వేరే ఇతర క్వాంటిటీస్ మీద డిపెండ్ కాదో వాటిని మనం ఫండమెంటల్ క్వాంటిటీస్ అంటాము. ఏ క్వాంటిటీస్ అయితే మనము ఫండమెంటల్ క్వాంటిటీస్ని ఉపయోగించి ఒక ఫార్ములా రాసి డిరైవ్ చేస్తామో వాటిని derived quantities అంటాము. Clear? So now next thing here, fundamental units and derived units. Fundamental units and derived units. Very simple here. The units which are used to measure fundamental quantities, that should be called here fundamental unit. ఫండమెంటల్ క్వాంటిటీస్ని మెజర్ చేయడానికి యూజ్ చేసేటువంటి యూనిట్స్నే మనం ఫండమెంటల్ యూనిట్స్ అంటాము. క్లియర్? అండ్ నౌ నెక్స్ట్ థింగ్ ఈజ్ హియర్ derived. What is meant by derived unit? The units which are going to be used to measure derived quantities, that should be what we call here derived units. For example, it is mass, it is there, that should be measured in terms of kg. Now kg is the fundamental unit, length meter and time second. Now we can go for here speed, distance for time. Distance is what? Nothing but length, meter, meter for second, meter for second. Now meter for second is called derived unit and these are called fundamental units. Clear children? So as for CGS, FKS, FBS, there are only 3 fundamental quantities, but according to SI there are 7 fundamental quantities. Let's see here. System of units, there are 4 system of units. They are CGS, FBS, MKS and SI. According to the CGS, FBS and MKS, there are only 3 fundamental quantities or 3 base quantities. They are mass, length, time. So how they can be measured in CGS, FBS and MKS? Let's see. So మనకి 4 సిస్టమ్ ఆఫ్ యూనిట్స్ ఉంటాయి, CGS, FPS, MKS అండ్ SI. ఈ CGS, FPS, MKS ప్రకారం 3 ఫండమెంటల్ క్వాంటిటీసే ఉన్నాయి. అవి లెంత్, మాస్, టైం. బేస్ క్వాంటిటీస్ అన్న ఫండమెంటల్ క్వాంటిటీస్ అన్న రెండు సేమే. ఓకే, సో చూద్దాం. అకార్డింగ్ టు CGS, length should be measured in centimeters, mass can be measured in terms of gram, time can be represented in terms of second. And according to FPS, length can be measured foot, mass pound, time second. And MKS, according to MKS, length meter, mass kilogram, time second. So dear students, here FPS is also called as British system. FPS also called as British system and CGS, MKS are established in France country. The General Conference of Weights and Measures held a meeting in 1971 and they decided one new system to measure the units. That is nothing but here International System of Units. International System of Units, and that can be abbreviated as SI according to the French. Lee System International D Unites. Lee System International D Unites. That should be SI came from this sentence. Clear? So according to the SI, there are 7 fundamental quantities or 7 base quantities. They are mass, length, time, electric current, thermodynamic temperature, and amount of substance, luminous intensity. These are the 7 base quantities. Along with that, there are 2 supplementary quantities are there. సో ఎస్ఐ ప్రకారం మనకి 7 ఫండమెంటల్ యూనిట్స్ ఉంటాయి, 2 సప్లిమెంటరీ యూనిట్స్ ఉంటాయి. ద సప్లిమెంటరీ క్వాంటిటీస్ ఆర్ ప్లేన్ యాంగిల్ అండ్ సాలిడ్ యాంగిల్. ఓకే, సో నౌ లెట్స్ గో ఫర్ యూనిట్స్. హియర్ base quantity, unit and symbol. So length, first one is length, mass, time, it is same as the MKS. Updated version of MKS is what? SI. Length, its unit is what? Meter. And symbol is what? Small m. Mass, what is unit? Kilogram. It is kg. And time, unit is second, s. Electric current, unit is ampere. So you can write small letters, you can write ampere. And symbol is capital A, because ampere is the scientist name. Thermodynamic temperature, Kelvin, and symbol is K, capital K. Amount of substance, mole, so MOL. Luminous intensity, its unit is candela, and symbol is CD. Symbol is what? CD. Okay, now plane angle is unit is what? Radian. So symbol is RAD. And for solid angle, unit is steradian, and symbol is SR. Let's see what are the rules to write the SI units. So the first thing here, look here, the name of the unit should be written in small letters. The name of the unit should be written in small letters. For example, here length unit is what? Meter. So meter is going to be write like this, small letters only. For example, current unit is what? Ampere. So symbol is what? Capital A. Even though it is capital A, you have to write the units in small letters like this, ampere. That is the first thing. And the first one, మనకి యూనిట్ నేమ్ ఏవైతే ఉందో దాన్ని స్మాల్ లెటర్స్తోనే రాయాలి. నెక్స్ట్ ఆర్ జనరల్లీ written with small letters. Here the same example, length is what? Meter, and that should be expressed like this, meter, small letter m, small m. What is small m? Length is what? Meter, like this. You have to write small letters only, చిన్న letters ఏ రాయాలి. సో మనకి next thing here, meter per second or meter second, like this. So it is the derived unit because of division. That should be written like this, m by s or m/s, and it is the meter second inverse, like that. So the thing is, here you have to observe all the units must be in small letters. So when the unit is not available with any scientist name, then the unit must be mentioned with a small letter s, small symbol. Okay, clear? Now otherwise, look here now, third one, if the units are available with the scientist name, then the unit symbol must be written with capital letters. Clear? So when we have units with the scientist name, then only you have to write the capital letters. Newton, N. Kelvin, capital K. Joule, capital J. Like that. So these are the names. Watt. So Newton, Kelvin, Joule and Watt. These are the units with the scientist names. They only mention with capital letters. Otherwise, we can go for the second rule only. Okay. And now fourth one. Symbols for derived units are written with the same some space. Symbols or derived units written with the some space. For example, momentum, mass into velocity, and its unit should be written as kg, some space, meter per second. So for example, Newton meter, Newton small space and m. Don't give any symbol like this, punctuation marks, commas like that, any that. Simply you have to leave some space, not that much of big one, only little bit space. Newton meter, joule second, like that. So symbols for derived units are written with the some space. And next rule, symbols for derived units which are obtained by the division of two units are written with the as like this symbol, or negative exponent or negative exponent. Just now only we discussed velocity, meter per second. It can be also written as here meter second inverse, meter second inverse. And now name of the unit may be plural, but the symbol is always singular form. Symbol is always singular form. For example, we are saying now 10 meters, 10 meters we are saying meters, this is the plural, but while you are writing that one, you have to write like this, 10 meter. Clear? Got my point? While you are writing the unit name, you have to mention the s, plural only you have to mention, but while we are mentioning as a number or writing the symbol, you have to keep only m, meter. So don't keep meters like this, it is the wrong. Simply you have to keep 10 meter only. And next, symbols do not end with the full stop unless they are at the end of the sentence. So while we are in any problem or while we are writing anything with the units, for example 10 newtons is the middle of the sentence, then don't keep 10 newtons like this. 10 newtons అనేది ఒక సెంటెన్స్ మధ్యలో ఉంది, ఒక ప్రాబ్లం ఉంది, దాని మధ్యలో ఉంది, then don't keep like 10 newtons, it is the wrong. Clear? So if any sentence is end with like 10 newtons, then you can keep here. అర్థమవుతుందా? ఏదైనా సెంటెన్స్లో మనకి 10 న్యూటన్స్ అనేది మిడిల్లో వస్తేనేమో మనము ఎటువంటి దాని పక్కన ఫుల్ స్టాప్స్ అనేది పెట్టకూడదు. ఒకవేళ సెంటెన్స్ అనేది దాంతో ఎండ్ అవుతుంటే యూ హ్యావ్ టు గివ్ ది full stop, no problem. So these are the rules to write the SI units in physics. Okay, the first thing is what? Here all the units must be written, unit names must be written small letters only. That's the first thing. And next one, the units should be mentioned, the unit symbols must be mentioned with small letters only. Third one, when any particular unit is available with the name of scientist, then the unit symbol should be mentioned with capital letter. So that is the name, starting letter of the scientist name, ampere, A, like that. Clear? And next thing, for derived units we have more than one or more than two units. While writing them in a unit, you have to give some little space between the letters. రెండులో అంతకంటే ఎక్కువ మనకి యూనిట్స్ వస్తున్నప్పుడు ఒక లెటర్కి ఇంకో లెటర్ అనేది కొంచెం స్పేస్ ఇవ్వాలి. అదే డివిజనల్ వచ్చింది అనుకోండి, బై స్లాష్ ఇవ్వాలి, మీటర్ పర్ సెకండ్, లైక్ దట్. ఓకేనా? అండ్ నెక్స్ట్ వన్ ఇస్ వాట్? హియర్ while we are writing the particular unit in the middle of the sentence, don't keep any punctuational marks like full stop, comma, semicolon, like that. Don't keep any like that. But while the sentence is closing with the or ending with the units, then you have to give the full stop, no problem. So these are the rules to write the SI units. Let's now discuss about the here common SI prefixes and symbols for multiples and submultiples. The numbers, numerical numbers what we are going to use in SI, they have different pronunciation and they have different symbols. You have to remember that. Here clearly mentioned on the board. Here 10 powers positive, here 10 powers negative numbers. That's how to understand. Here which are getting here positive, they can be called as here multiples, and these are the submultiples. What we are adding to the power of 10, that should be called as here submultiples. Clear? So multiples lo manaki ila untayi, submultiples lo ila untayi. Aventi chuddam. Look here now. Factor 10 to the power of 18, that should be known as hexa, and the symbol is E. 10 to the power of 15, peta, pronunciation is P, symbol is P. Here 10 to the power of minus 18, atto, A. 10 to the power of minus 15, femto, symbol is F. Here 10 to the power of 12 plus 12, tera, capital T. 10 to the power of minus 2, 12, pico or pico, that is here symbol P. And 10 to the power of 9, here it is giga, and it is symbol is capital G. 10 to the power of minus 9, nano, symbol is N, small n. And 10 to the power of 6, mega, capital M. 10 to the power of 6, mega, capital M. And 10 to the power of minus 6, macro, symbol is mu. 10 to the power of 3, kilo, the symbol is here small k. Up to E to M all are capital, now it is kilo is small k. And 10 to the power of minus 3, milli, that should be shown here small letter m, small m. And 10 to the power of 2, what we call it is hecto, symbol is H. 10 to the power of minus 2, centi, symbol is small c. And now here 10 to the power of 1, deca, what is 10 to the power of 1 is what? Deca. So DA, DA. And 10 to the power of minus 1, deci, 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 it is small d. So these are the multiples and submultiples we are going to use in SI. Clear? Now let's see the definitions of base quantities. The first series here, meter. Meter is the unit of length. How we can define the meter? Look here, meter is the distance containing 16,50,763.73 wavelengths in vacuum of radiation corresponding to the orange or red light emitted by the krypton. This is the definition of meter. What it means? In case of krypton, if the transition takes between the 2p10 to 5d5, so levels 2p10 to the 5d5, if the transition is going between those two, then some energy is emitted. For that, this much of times 16,50,763.73 times it is there, then that is called here meter. So krypton lo మనకి 2p10 నుంచి 5d5 వరకు మధ్య ట్రాన్సిషన్ జరుగుతున్నప్పుడు ఎంత వేవ్ లెంత్ అయితే ఎమిట్ అవుతుందో ఆ వేవ్ లెంత్ యొక్క రేడియేషన్ ఎంత ఉంటుందో ఆ రేడియేషన్కి ఈ నెంబర్ ఆఫ్ టైమ్స్ తీసుకున్నప్పుడు అది ఒక మీటర్కి ఈక్వల్ అవుతుంది అంటున్నాడు. సో దీనికి ఇంకో డెఫినేషన్ చూడండి. Meter is defined as the length of the path traveled by the light in vacuum in 1/299792458 part of a second. Clear? So simply here 299,79,02,458. So this much of part of the time. So ఒక సెకండ్లో ఇంత పార్ట్లో ఎంత టైంలో ఒక సెకండ్లో ఇంత టైంలో మనకి ఈ లైట్ అనేది ఎంత డిస్టెన్స్ ట్రావెల్ అవుతుందో దాన్నే మనం మీటర్ అంటున్నాం. ఓకేనా? మీటర్ ఇస్ డిఫైన్డ్ యాజ్ లెంత్ ఆఫ్ ద పాత్ ట్రావెల్డ్ బై ద లైట్ ఇన్ వాక్యూమ్ ఇన్ 1 second of this watch. ఒక సెకండ్లో ఈ నెంబర్ ఎంత పాత్ తీసుకున్నప్పుడు ఎంత డిస్టెన్స్ ట్రావెల్ అవుతుందో దాన్ని మనం మీటర్ అంటున్నాం. ఓకే, నెక్స్ట్ వన్, మాస్. వాట్ ఈజ్ మాస్? దెర్ ఈజ్ నో ఎగ్జాక్ట్ డెఫినేషన్ ఫర్ ది మాస్ kilogram. Here it is there, kilogram. So here no exact definition for kilogram. So what is the base quantity here? Mass, and its unit is what? Kilogram. So the kilogram is nothing but here alloy. It's an alloy of platinum and iridium. They are taken some here cylinder of platinum and iridium. Look here, kilogram is the mass of a platinum iridium cylinder kept in International Bureau of Weights and Measures at Paris. ప్యారిస్లో బ్యూరో ఆఫ్ వెయిట్స్ అండ్ మెజర్స్ అనేటువంటిది వాళ్ళు తీసుకున్నటువంటి రిఫరెన్స్ ఏంటి? సిలిండర్ ఆఫ్ ప్లాటినం అండ్ ఐరిడియం. సో దాని యొక్క అలాయిని తీసుకొని దాన్ని మనకి ఒక వెయిట్గా తీసుకొని ఆ వెయిట్ యొక్క వాల్యూని ఒక కిలోగ్రామ్గా డిఫైన్ చేయడం జరిగింది. నెక్స్ట్ సీ ద డెఫినేషన్ ఆఫ్ సెకండ్. Second is the unit of time, fundamental quantity time. See the definition here. The second is the duration of 919 crores 26 lakhs 31,770 periods of radiation of correspond to the transition between the two hyper levels of the ground state of cesium atom. The second is the duration of 919 crores 26 lakhs 31,770 periods of radiation of corresponding to the transition between the two hyper levels of ground state of the cesium 133 atom. cesium atom యొక్క గ్రౌండ్ స్టేట్లో మనకి ఏవైనా రెండు హైపర్ లెవెల్స్ మధ్య ఇన్నిసార్లు ట్రాన్సిషన్ కావడానికి పట్టే టైం ఎంత టైం ఉంటుందో ఆ టైము ఈక్వల్స్ టు సెకండ్ అంటున్నాడు. సెకండ్ ఈజ్ ద డ్యూరేషన్ ఆఫ్ 9192631,770 periods of radiation correspond to the transition between two hyper levels. ఆ రెండు లెవెల్స్ మధ్య రేడియేషన్ ట్రాన్స్మిట్ అవ్వడానికి ఇన్నిసార్లు అవ్వడానికి ఎంత టైం పడుతుందో ఆ టైంనే మనం సెకండ్ అంటున్నాము. ఇట్ వాస్ గివెన్ ఇన్ 1967 డెఫినేషన్. నెక్స్ట్, ఆంపియర్. ద ఆంపియర్ ఈజ్ దట్ current which if maintained in two straight parallel conductor of infinite length of negligible circular cross section and placed 1 meter apart in vacuum would produce a force equals to the 2 into 10 power of minus 7 newtons per meter of the length. So the ampere is that the current. Ampere ni ela define chestaru ante, look here, these are the infinite length of conductors and they should be kept 1 meter distance of separation. Clear? రెండు పెద్ద లెంత్ ఎక్కువ ఉన్నటువంటి ఇన్ఫినైట్ లెంత్ ఉన్నటువంటి రెండు వైర్స్ తీసుకున్నప్పుడు లేదా రెండు కండక్టర్స్ తీసుకున్నప్పుడు వాటి మధ్య 1 మీటర్ ఉన్నప్పుడు అవి రెండు వాక్యూమ్లో ఉన్నప్పుడు ఆ రెండిట్లో ఒకే విధమైన కరెంటు వెళ్తున్నప్పుడు మనకి ఒకదాని మీద ఒకటి ఫోర్స్ ఎంత ఉంటుందంటే ఒక కండక్టర్ అనేది ఇంకో కండక్టర్ మీద ఎంత ఫోర్స్ అప్లై చేస్తుందంటే 2 into 10 power of minus 7 న్యూటన్స్ ఫోర్స్ని అప్లై చేస్తుంది. అప్పుడు ఆ కండక్టర్స్లో ఉన్నటువంటి కరెంట్ని ఏమంటారంటే ఈక్వల్స్ టు 1 ఆంపియర్ అంటారు. ఓకేనా? ఏవైనా రెండు ఇన్ఫినైట్ లెంత్ ఉన్నటువంటి వైర్స్ తీసుకున్నప్పుడు when they are maintained a distance of separation is 1 meter and they are carrying the some current I, when they can exhibit the some force 2 into 10 power of minus 7 newtons per length, meter per length each other, then the amount of current in the conductor should be called as ampere. So ఇది మనకి 1948లో ఇచ్చాడు. నెక్స్ట్, కెల్విన్. Kelvin is the 1/273.16 of the thermodynamic temperature of triple point of water. Kelvin is the 1/273.16 of the thermodynamic temperature of triple point of water. వాటర్ యొక్క ట్రిపుల్ పాయింట్ వాల్యూలో 1/273.16 పార్ట్ని ఏమంటారంటే కెల్విన్ అంటున్నాం. వాట్ ఈస్ కెల్విన్ హియర్? Kelvin is the unit of thermodynamic temperature. Thermodynamic temperature is the base quantity and its unit is Kelvin. Okay, so that is about the Kelvin. And next one is mole. Mole is the unit of amount of substance. Base quantity what it is? Amount of substance and its unit is mole. It can be defined like this. The mole is the amount of substance of the system which contains the as many elementary entities as there are atoms in a 0.012 kilogram of carbon. సో మనకి 0.012 కిలోగ్రామ్ ఉన్నటువంటి కార్బన్లో ఉండేటువంటి స్మాల్ ఎంటిటీస్ అయిన ఆటమ్స్ ఏవైతే నెంబర్ ఉంటుందో దాన్ని వాడు మోల్ అంటున్నాడు. క్లియర్? సీ వన్స్ అగైన్, the mole is the amount of substance of the system which contains as many elementary entities as there are atoms in 0.012 kilograms of carbon. సో ఇంత 0.012 కిలోగ్రామ్లో ఉన్నటువంటి కార్బన్లో ఉన్నటువంటి ఆటమ్స్ యొక్క నెంబర్ని వాడు వాజ్ గివెన్ యాజ్ మోల్. క్లియర్? నెక్స్ట్ క్యాండిలా. వాట్ ఈస్ క్యాండిలా? క్యాండిలా ఈజ్ ద యూనిట్ ఆఫ్ fundamental quantity luminous intensity. How we can define it? Let's see here. Candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of 540 into 10 power of 12 Hz and that has radiant intensity in that direction of 1 by 683 watt per steradian. Candela is the luminous intensity. క్యాండిలా అనేది లూమినస్ ఇంటెన్సిటీ యొక్క యూనిట్. దాన్ని ఎలా డిఫైన్ చేస్తుందంటే ఇది ఒక లూమినస్ ఇంటెన్సిటీ ఎలా అంట, ఇన్ ఏ డైరెక్షన్ ఆఫ్ సోర్స్ దట్ ఎమిట్స్ ఏ మోనోక్రోమాటిక్ రేడియేషన్ ఆఫ్ 540 into 10 power of 12 Hz. ఒక మోనోక్రోమాటిక్ లైట్ని ఎమిట్ చేసేటువంటి ఒక సోర్స్ ఉంది, దాని యొక్క ఫ్రీక్వెన్సీ ఏంటంట 540 into 12 Hz. అంతటి ఫ్రీక్వెన్సీ ఉన్నటువంటి రేడియేషన్ ఎమిట్ చేస్తున్నటువంటి సోర్స్ యొక్క ఇంటెన్సిటీనే మనము దాదాపు 1 by 683 వాట్ పర్ స్టెరేడియన్ తీసుకుంటున్నాం. దాని యొక్క రేడియేషన్ ఇంటెన్సిటీలో 1/683 తీసుకుంటే దట్ ఈస్ వాట్ వీ కాల్ క్యాండిలా. అండ్ నెక్స్ట్ సప్లిమెంటరీ యూనిట్స్. రేడియన్. రేడియన్ ఈజ్ ద యూనిట్ ఆఫ్ plane angle. So the definition should be like this. It is the angle between the two radii of a circle which cut off from the circumference an arc equal to the length of the radius. So it is nothing but ratio. It is what? Angle between, nothing but this is the angle. So this is the one radius and this is the another radius vector. Then the angle between these two is what? D theta. This d theta should be taken as plane angle, and that should be how we take it as ds by r. This is the arc. What is nothing but arc. That arc should be equal to the radius. Okay. So then ds by r radian. So plane angle is equals to ds by r radian. This is about the radian definition. Now see the definition of steradian. Steradian, it was adapted as the unit of solid angle with its effects at the center of the sphere that cuts out an area on the surface of the sphere equal to the area of the sphere. Those sides are equal to the radii of the sphere. Clear? It was adapted as the unit of solid angle with its effects at the center of the sphere that cuts out an area on the surface of the sphere equals to the area of the sphere. Those sides are equals to the radius of the sphere. So solid angle in steradian is equals to length of the arc radius. So to understand it simply, here we are taking one solid sphere is there. In that solid sphere we have to cut like this. So here children, this is the solid angle. This one is what it is. You have like this. This is the solid angle. So that should be here. I am showing like this. This is the solid angle like this. That is what delta A by r square unit steradian. Clear? In that what it is, del dA is the area, dA by r square. We have to cut this area that is almost all equals to the surface area of the sphere. You are saying that, and what we are taken like in shape of arc, that should be also equals to the radius of the sphere. Look here once. With its effects at the center of the sphere that cuts out an area on the surface of the sphere equals to the area of the sphere. ఏమన్నాడు? an area on the surface of the sphere equals to the area of the sphere. ఒక సాలిడ్ స్పియర్లో మనం కొంత ఏరియా కట్ చేసినప్పుడు, సర్ఫేస్ కట్ చేసినప్పుడు అది మనకి సర్ఫేస్ ఏరియాకి ఈక్వల్ కావాలంటున్నాడు. ఓ సైడ్స్ ఆర్ ఈక్వల్స్ టు ది రేడియస్ ఆఫ్ ది స్పియర్. ఏవైతే మనం సైడ్స్ తీసుకున్నామో ఆ సైడ్స్ అనేవి దాని యొక్క రేడియస్కి ఈక్వల్గా కావాలి అంటున్నాడు. ఓకేనా? సో సాలిడ్ యాంగిల్ ఈజ్ ఈక్వల్స్ టు డెల్టా dA by r square steradian. So this is about the steradian and that is the unit of solid angle. Now let's discuss about some practical values practical units of length, not contained in SI units. Other than SI units, we have some units are there. For what? Length. Let's see. 1 micron is equals to 1 mu, that is equals to 10 power of minus 6 meters. 1 nanometer, nm, 1 nanometer is equals to 10 power of minus 9 meters. These values are very useful during the any calculation given in the problems. So that's why you have to remember that. And 1 angstrom is equals to 10 power of minus 10 meters, 10 power of minus 8 centimeters, and that is also expressed as 10 power of minus 4 micrometers. And next, 1 Fermi is equals to 10 power of minus 15 meters. And 1 astronomical unit is the average distance between the any two planets. That should be taken as astronomical unit, and that is what here 1.496 into the power of 11 meters. And if you can round it off, it can be written as 1.5 into the power of 11 meters. And 1 light year, the distance traveled by the light in vacuum in 1 year, that should be called light year, and that should be equal to here 9.467 into the power of 15 meters. And 1 parsec, that is equals to 3.08 into the power of 6 meters and 3.26 light years, and that is equals to what? 207 AU, astronomical units. So we have to observe, while we are coming from top to bottom, the magnitude is increases. Clear? That's why here the maximum unit is here to find out the largest distance. What is parsec? సో మనకి ఇచ్చినటువంటి వాటిల్లో ఏవైతే మనం లెంత్ ఫైండ్ అవుట్ చేయడానికి మనం యూజ్ చేసేటువంటి హైయెస్ట్ ఆర్ మ్యాక్సిమం డిస్టెన్స్ కనుక్కోవడం యూజ్ చేయండి పార్సెక్. సో దిస్ అబౌట్ ది ప్రాక్టికల్ యూనిట్స్ ఆఫ్ లెంత్. నౌ లెట్స్ డిస్కస్ అబౌట్ ది practical units of mass. So the largest unit is this one. So మనం mass ని find out చేసే units లలో highest top, this is the largest one unit. So what it is? Chandrasekhar limit. So it should be shown like CSU, Chandrasekhar unit. How we can show that? CSU. Okay, so it is the 1.4 times of the mass of the sun. 1.4 times of the mass of the sun. సో చంద్రశేఖర్ యూనిట్ అనేది మనకి తీసుకున్నప్పుడు మాస్ సన్ యొక్క మాస్ కన్నా 1.4 టైమ్స్ ఎక్కువ ఉంటుందంట. దాని వాల్యూ ఈస్ ఈక్వల్స్ టు ది 2.8 ఇంటూ 10 పవర్ ఆఫ్ 30 కేజీ. 10 పవర్ ఆఫ్ 30 కేజీ. దీని ఎట్లా కూడా రాసుకోవచ్చు, 28 ఇంటూ 10 పవర్ ఆఫ్ 29 కేజీ కూడా రాసుకోవచ్చు. ఓకే, సో దట్ ఈస్ ద ఫస్ట్ వన్. And so this is a well known to all. Metric ton 1000 kg, 1 quintal 100 kg, and this is the another important one. Atomic mass unit 1 AMU. It is equals to the 1/12 of mass of carbon. 1/12 of mass of carbon. That should be what we call here 1/12 of mass of carbon is called 1 atomic unit, 1 atomic mass unit. Clear? సో కార్బన్ తీసుకున్నప్పుడు ఆ కార్బన్లో మనం 12 పార్ట్స్గా ఇమాజిన్ చేస్తే ఆ చేసినటువంటి దాంట్లో ఒక పార్ట్ యొక్క మాస్ ఎంత ఉంటుందంట? 1 AMU. అండ్ యూ హ్యావ్ టు రిమెంబర్ దిస్ వన్, 1.67 into 10 power of minus 27 kg. చిల్డ్రన్, 1.67 into 10 power of minus 27 kg. సో చిల్డ్రన్ అనేది అలవాట్లో పొరపాటు వచ్చేస్తుంది, డోంట్ ఫీల్. 1.67 into 10 power of minus 27 kg. 1 AMU is equals to this value is important. And you have to remember this one, mass of proton or mass of neutron should be order of 1 AMU. So AMU లో చూపిస్తాం, ఓకేనా. And now 1 slug is equals to 14.57 kg, and 1 pound is equals to 0.4536 kg. So maximum it మనకు యూజ్ చేయం. So these are very important for 1 2 3 4. Let's see now some practical units of time. So century, it is the largest unit of time. Century means 100 years. What is the definition of year? The time taken by the earth to complete the one rotation around the sun in its orbit. That should be what we call here year. So ఎర్త్ అనేది సన్ చుట్టూ ఒక రొటేషన్ చేయడానికి పట్టే టైంని మనం 1 year అంటాం. దాని వాల్యూ ఎంతంటే 365.25 డేస్. 365.25 డేస్. ఇన్ సెకండ్స్ 3.156 into 10⁻7 seconds. Okay, and next thing, lunar month. It is the time taken by the moon to complete one revolution around the earth in its orbit, like LM. So 1 LM is equals to 27.3 days. 1 lunar month is equals to how many days? 27.3 days. Per year 365.25. Okay, and now one solar day around the sun. That should be here what we call year, but in case of solar day, the time taken by the earth to complete one revolution around itself. So సూర్యుని చుట్టూ తిరిగితే ఇయర్ అంటాము, అరౌండ్ ఇట్ సెల్ఫ్ అంటే సోలార్ డే అంటాము. ఓకే, సో 1 solar year 365.25 days. Average solar year is equals to 1/365.25 of the part of the solar year, because the location of the earth should be changes with respect to the time. That's why here the solar day can be varies. That's why here we will consider the average solar year 1/365.25 the percentage of solar year. And next, sidereal day. It is the time taken by the earth to complete one revolution with respect to the distant star. ఇంతకుముందు అన్ని సందర్భాల్లో with respect of, in previous all cases with respect of sun, and now it is with respect of distant star. Clear? That is what we call sidereal day. And now here 1 solar year is equals to 365.25 sidereal days. Almost all same. The only variation is here. This is the important one. Sidereal day is less than 1 solar day is by 4 minutes. So solar day కన్నా sidereal day అనేది 4 minutes తక్కువ ఉంటుంది. Less than the 1 solar day is how much? 4 minutes. So this is about the some practical units of time. So dear aspirants, if you can understand what I explained in this video, please like, share, comment the video. So aspirants నుంచి వచ్చిన రెస్పాన్స్ బట్టి పీజీటీ ఫిజిక్స్, టీజీటీ సైన్స్, దాంట్లో ఫిజిక్స్ కెమిస్ట్రీ పోర్షన్ మొత్తం కూడా చెబుదామనే ఉద్దేశంతో ఉన్నా. సో మీ నుంచి మంచి ఫీడ్బ్యాక్ వస్తే ఐ విల్ ప్రొసీడ్. ఓకే, థ్యాంక్ యూ ఫర్ వాచింగ్.